Hey everyone, well, I'm just going through the problems in that packet that I sent today, starting with number 1A, where I have the log base square root of 17 uh, of square root of 17 to the negative 8, plus the log base pi of 1. Well, they're just being a little tricky here. Log base anything of anything to a power is just that power, and the log base anything of 1 is always just a 0, because we're really saying pi to what power equals 1, and so my answer is just negative 8. In part B, they are saying that 3 times the natural log of e, oh, that goes away, plus 6 times the natural log of 1, oh, e to what power equals 1, e to the 0th, so plus 0, plus e to the natural log of 9, e to the natural log of 9. Well, e and natural log kind of cancel out. I'm really left with 3 plus 9. My answer is 12. In 2, they tell me that t equals the log of x. They tell me that w equals the log of y, and they want me to write the log of 100x rad y with t's and w's. That would be the log of 100 plus the log of x plus the log of y to the 1/2. Oh, well, that 1/2 can come on down in front. Log of 100 is 2 plus t plus 1/2 of w, and we're done with that one. Write expression as the sum and or differences of logs. They started with the natural log of a whole big ugly thing, 2x cubed times the square root of x plus 3. And on the bottom, I have an x plus 1 and an x plus 4. We can just go right at it. Natural log of 2 plus 3 times the natural log of x, because the exponent becomes a coefficient, plus 1/2. Once again, the exponent for a square root is 1/2. The natural log of x plus 3 minus the natural log of x plus 1, and minus again the natural log of x plus 4. Easy enough. Number 4, we're going backwards. Number 4, they start us with 1/3 the log base 5 of x plus 1 minus log base 5 of x squared minus 4, and plus the log base 5 of x plus 2. We are going to condense this. We are going to write it as the log base 5 of the cube root of x plus 1 times x plus 2 and over x squared minus 4. Can I write that as x plus 2, x minus 2, and cancel those guys out? Reminding myself that x may not equal negative 2, which I think is not real important to do anyway, because that would be outside the domain of log. So I'm going to leave it like that. Number 5, multiple choice, circle the right answer. Let's get a new sheet of paper here, and they are saying the log base b of c times the log base c of square root of b. Well, I'm going to use my change of base formula and write this as the natural log of c over the natural log of b times the natural log of b to the 1/2. Well, that 1/2 can only sneak in front and be that coefficient over the natural log of c. A lot of stuff cancels out, and I'm just left with that 1/2. So my answer, of course, is B. Express y as a function of x. We did this one in class, I feel, or at least we talked about it. I guess I'll just do it again. Natural log of y equals 2x plus the natural log of k. I'm going to write this as natural log of y minus natural log of k equals 2x. I'm going to write this as natural log of y over k equals 2x. I'm going to throw in some e's and get that y over k equals e to the 2x, and therefore y equals k e to the 2x. I'm be done with that one. Don't think we did it in class now that I say it out loud. Number 7. This one I feel like we did do in class, number 7a. I feel like I should skip that. 7b looks to be a very similar concept here. 7b, they said the log base 6 of x plus 4 plus the log base 6 of x plus 3 is equal to 1. I'm going to say the log base 6 of x plus 4 times x plus 3 is equal to 1. I'm going to say that 6 to the 1th, 6 is equal to this, which is x squared plus 7x plus 12. When I subtract 6 from both sides, I end up with a quadratic. X squared plus 7x plus 6. That to me says 0 equals x plus 6 times x plus 1. X equals either -6 or -1. That one is outside the domain, but this one is not, because I'm taking the log base 6 of -1 plus 4. Oh, that's 3 and 2. Okay, seems good to me. Looks like I'm gonna have to break out some more paper. Got some more right there. Let's see what the next problem looks like. Solve each exponential equation. I feel like we definitely did this one in class. I'm going to write it along with the punchline. 2 plus x equals 5 to the 1 minus 3x. And if I take the natural log of both sides, I end up with 2 plus x times the natural log of 3 equals 1 minus 3x times the natural log of 5. Distribute, move everything with an x to one side, everything without an x to the other side, factor out the x, divide by all of those good things. Moving right along, I've got 2 times 49 to the x minus 11 times 7 to the x equals -5. This one, I feel like they're being a little bit sneaky by saying 2 times 7 squared to the x minus 11 times 7 to the x equals -5. My parentheses aren't really doing much good for me here. In fact, they're making it harder for me to see that if I call 7x equal to a, I can rewrite this as 2a squared minus 11a plus 5 equals 0. Again, we seem to have a quadratic. Let's try to factor that. The factors of 2a squared are 2a and a. The factors of 5, or a 5 and a 1, we'll make them all negative. 2a times -5 is -10, minus another 1 is that -11. That seems to work. So apparently a equals either positive 1/2 or a equals positive 5. Both of them seem okay to me. That is 7 to the x equals 1/2. That is the natural log of 7 to the x. So x times the natural log of 7 equals the natural log of 1/2. x equals natural log of 1/2 over natural log of 7. Same treatment over here. This would be 7 to the x equals 5. We would get x ln 7 equals ln 5, or x equals ln 5 over ln of 7. Is an answer to that one. What else do we have? That was 8. That was it. Woot woot. Okay, let me send this recording out, and hopefully that was useful. Boop, and end meeting.